Hi everyone, if you are an early career scientist or perhaps a prof wanting to expand your knowledge, then this is the video for you. If you are in these sort of scientific fields, then you've probably heard about the statistical programming language called R. For those of you who don't know, R is a stats program that you can use to manipulate your data, perform analyses and create beautiful graphs and much more. But is it really worthwhile taking the time to learn this programming language? Today, let's look at 10 reasons why you should. Number 1, it's free. Some of the most highly acclaimed statistical programming language out there, such as SSPS, MATLAB and Statistica, you require some sort of paying license to be able to use the program based on the number of computers you have the programs installed on. But what if I told you that you can get the same result for free? Let's not take away the power of these stats programs. If you can afford it, good for you and use it. However, buying these programs can be very expensive, and you can be quite limited by the analyses that you can perform. R does not have these problems. R is easy to install and completely free. For example, if you are an educator and you need to teach your students, postgraduate or undergraduate, how to do statistical analyses on their data, these students can install the R program for free on their own personal computers. And on their own PCs, they can learn for free, take it home and keep practicing. And the best of all, you might think that the R programming language is just some code that runs in the background. Well, you'll be completely wrong. R comes with a free Integrated Development Environment, or IDE, known as RStudio, which is very convenient and easy to use. Number 2, R is easy to learn. Unlike many other programming languages, R is not a stickler when it comes to spacing, indentations, or declaring the end of line. These little technical details can make you pull your hair out. To be honest, I can't even count the number of times I've sat in the corner and cried myself to sleep because of a semicolon. The lack of these little syntax details makes R very easy to learn. The fact that you can run your code in RStudio and actually in real time visualize your output makes R very easier and convenient to use, and it makes it very easy for you to learn from your mistakes. Just to give you an idea, if you stick to it, you can learn how to take a complex set of data, analyze the data and create beautiful graphs in about a weekend. And R is a great way to introduce you to the world of programming. Once you've learned R, it'll be very easy to pick up the syntax of other programming languages, and I advise you to do so. Number 3, great support. One thing you need to understand about programming is that every programming language has a base set of functions for you to use. However, if you want to do a bit more complex tasks, then you have to employ third-party packages or libraries. For example, in R, using the base programming, it will be very difficult for you to program an interactive map. However, if you employ the ggmap package, it'll be quite easy to do so. But how do you use these packages, and what happens when you start seeing errors in your output? Well, R makes this a very easy hurdle to overcome. Now, if you use these packages from other languages, you inevitably will run into some sort of error. Now, usually there's some sort of support online. However, for other languages, these are often not helpful at all, difficult to find, or incomplete. And trust me, this can be extremely frustrating. In R, the support is conveniently located in the RStudio program, and it's standardized to a certain format. For example, for each function, the author has to declare how the data should be formatted, the types of parameters and what they do, and as well as provide some examples and some detailed description about how the function works. And like I mentioned earlier, you don't have to do an internet search to find the help. It's all conveniently located within the RStudio IDE. And trust me, when you're in a pinch, this makes the world go round. Number 4, control. When using pay-to-play programs, you're often limited by how the output can be formatted. For example, in Excel, when creating a graph, you are usually limited by the number of color options and graph layouts, and sometimes this is just not enough. In R, you have virtually complete control about how your output is formatted. If you want a random line in the middle of your graph to illustrate some sort of limit, go for it. Do you want to combine two y-axes on one x-axis graph? Why not? Do you want to overlay a map on your graph to display the different types of radiation or levels of radiation at different sides of the river? You can do it. And with control of your output, so comes the understanding of the R language. The more you learn, the more you will be able to do. Number 5, diverse applications. Other stats programs can only do stats. R is extremely diverse. R gives you the freedom to use your own creativity without the limitations of pre-programmed software. With your data in Excel, you can't start doing phylogenetic analysis. However, in R, you can do complex statistical analyses and phylogenetic analysis all within the same segment of code. Although R was originally created for statistical analysis, you can do almost anything you can think of if you find the right package. You can create graphs, websites, interactive data visualizations, maps, and much more. If you have a unique application for which there is no package, just create your own. Let's say that you created an equation to estimate the number of genetic mutations that occur in a human over a fixed period of time under certain conditions. Simply take that equation, put it into an R function, and analyze your data. R is truly powerful and is only limited by your creativity. Number 6, compatibility. An understandable concern when deciding to switch to the R program is, can I transfer my pre-calculated data to R? Well, let me set your mind at ease. R acts as an intermediate between statistical software and other programming languages. Let's say all of your data was compiled in Excel. You can easily import your Excel data as a comma-separated values file into R, or you can even just import the datasheet itself. It gets better. Once imported, you can analyze your data, manipulate the data, create graphs, and you can export everything back into an Excel file. If you wish to use your R script as part of a larger program, this can be done. Let's say, for example, you had an application in Python, another handy programming language, and you want to send the output to R for statistical analysis. You can do so, and that output can be sent back to Python for further applications. If you only want to use R to manipulate your data to get it ready for other programs, you can do so. Simply export it as a CSV file and import it into MATLAB or Statistica or so on. Whatever format your data may be in, R can probably handle it and humanize your results. Number 7, publishable results. Once you start getting the hang of programming in R, the obvious next step is to show the world your results. You can go look for yourself, but it's very popular to use R for statistical analysis in both high and low impact peer-reviewed journals. The main reason for this is the reliability of the R programming language. Also, you can actually publish your code so that other people can check your results or use that code for their own applications, which is the ultimate compliment. In my humble opinion, there's no match for the beautiful visualizations that R can create, and it truly makes it a pleasure to read a publication. Ultimately, learning R gives you the confidence to publish your findings with pride. Number 8, automation. Let's see if this sounds familiar. You're sitting next to a river somewhere, year after year for 4 years, collecting data on some sort of biological observation, and now you've got all of this information to analyze. Periodically, you accumulate a large amount of data, and usually there's a gap between sampling sessions. Now, curiosity will get the better of you, and you will want to start to analyze your data. If you prepare and analyze your data in a program such as Excel, you would usually have to redo all the formulations and calculations as the next set of data comes in. This is because the number of data entries may change, or due to some unforeseen circumstances, the entire format of your data may be altered. When programming in R, you can analyze your data with the same script, making minor adjustments in some cases. This also allows you to standardize the way the analysis is performed on your repetitive data, and you are also able to perform more complex analysis without altering the code in such a major manner. This also makes it easier to standardize how the analysis is conducted on your repetitive data, and it also allows you to perform more complex tasks without repetitive coding. Now, some of you Excel fans out there might be saying, yeah, but you can formulate your spreadsheets to act as automation for your data. Well, yes, you can, but should you? Look, Excel certainly has its place, and few programs beat Excel when it comes to recording your data in a spreadsheet format. But for analysis and automation, use R. Number 9, you can contribute. As you become more apt in R, inevitably you will have written your own clever function or set of functions. Now, some of you would want to keep that code for yourself, but as I always say, knowledge belongs to no one. If you think your code could help other people that might have similar problems, you can easily create your own package and put it out there for people to use. It doesn't have to be complicated. Let's say you created a simple function to convert Celsius to Fahrenheit. You can simply publish that function and other people can use it. Now here's the best part. If it's really good and has a broad application and a potential large audience, then you can publish this package in a peer-reviewed journal. Number 10, increase employability. At the end of the day, learning R is a way to improve your skill set and expand your CV. Adding R to your skills repertoire certainly makes you more sellable to a prospective employer. Yes, it's true, money isn't everything, and that's certainly not why I got into science. But hey, smiles don't put food on the table. And here's a fact, people with a competency in R is in high demand. Now have a look at postdoctoral fellowship requirements in the field of biology with a bioinformatics component. I guarantee you that most of them will mention R as a big selling point. And everyone, that was my list. I really hope I inspired you to start learning R. Check out the description for R download links. You can download and install R yourself on your personal computer. Remember to install the R programming language first and then R Studio. Please go have a look at my ResearchGate and ORCID ID so that you can see the type of research our lab is doing. Now this is usually the part where people would pester you to like and subscribe. I honestly don't care. This video was not for me, it was for you. Stay safe, stay smart, and thank you for watching.